Hello everyone and welcome to my channel. We have already seen how to define identity, but a processor with a memory is like a calculator with an equals button. It operates but it doesn't remember. In symbolic prompting, a variable is not just a word. It's an state container. It allows us to label information so that the artificial intelligence doesn't have to reread the entire context, but simply consult the value we have stored. Before diving into variables and encapsulation, we need to look at some symbols that are important for symbolic prompting. Definition and constant. Establish the rule values that should not change. Next, indicate an operation that must be executed. Dynamic assignment. Assign a value that can change. Indicates that a specific action should be executed using data block that follows. Define the start of a static data container. Group related attributes with curly brackets, like an object. A data block that also has associated processing rule. Explicit delimiters that tell the artificial intelligence here the information begins and here it ends, preventing it from mixing with subsequent instructions. Remember these symbols. If you have doubts about their meaning, I leave the link in my GitHub in the video description. Let's dive into variables. A symbolic variable is a name container. It stores a value that the artificial intelligence can read and modify. Variables have a name, a value is assigned to them, and an state within this set of all variables. A global variable is visible throughout the entire execution. Any function, any submodule, any rule can access the global variable. It is recommended to define them at the beginning so as not to affect the behavior of the prompt. They are constant. Their characteristic scope throughout the entire system. They last as long as the context lasts. There is a risk, and that is that they can be modified during the flow of the prompt. Useful for global configuration, dangerous if any function modifies them without control. Isolation. They don't contaminate the rest of the system. Temporary. They are born and die with the function. Security. No one external can alter them. A local variable only exists within the function. Observe it, no one can see them or they cannot be used. The local discount lives only inside a specific offer. Outside, it cannot be modified. This is what the difference between global and local variables looks like. Encapsulation is the principle that a function should be a black box. Whoever calls it does not need to know how it does what it does, only what it does. The function reads the global, but it doesn't modify it. It respects isolation. It is predictable. Although it is a short example when dealing with a smart function or a small encapsulation. It is not so good. To use global variable, it's better to use local. If the prompt is going to be large with different function or encapsulation, then it's good to define both global and local variables. Global state. The function check stock. Next function sell. System use. We see the results. Check stock returns 50 apples to us. The next function sells 3 apples, and the final state returns 37 apples to us. As we can see, this is no longer just a prompt. This is a program, right in symbolic prompting. We have given the artificial intelligence variables a scope and operations. In this example, we could see how local and global variables are defined. Likewise, but local and global variables are modified. For global variables, it's better to define threshold, system constants. Try not modify them. Avoid using counters, temporary variables. Use it with functions or encapsulation. Remember, it can only be used inside of this. Every time you define a function or encapsulated block, establish a clear closing delimiter, like n underscore function, or simply an explicit separation line. This prevents the artificial intelligence from spilling the instruction from one block into the next. You already have memory, you already have scopes, you already have encapsulation. Now you need your program to make decisions. Remember these symbols. They will be very helpful in the next videos. Encapsulation reduces side effects. Pure functions are more predictable and easy to understand. Global variables are useful for initial configuration. So far, we have created memory and structure. But a program without the ability to decide, it is like a robot that only knows how to move forward. In the next video, we will give it the ability to choose the path, if then else. If you like this video, don't forget to like in the icon and subscribe to my channel. See you in the next video.